Today I'm going to cover a few topics. We're going to go over ice cream and freezers and spend a little bit more time than we did yesterday with like the apple trees when I had to rush through that. We're going to talk about code style and inheritance as well, and those should be fairly quick. I want to spend most of today's time on ice cream and freezers. By this point, most people have tackled this or kind of taken a look at it. And the idea was basically I have different classes and I need them to interact with each other. I also need to worry about how I'm going to use my instance variables, how I'm going to call different methods, how I'm going to pass objects from one class to another. And the idea is basically you are a web developer and you're helping your friend with I Heart Ice Cream. It's a creamer that makes delicious ice cream, and they need some software to help them manage their kitchen. Up to this point, it's just been one person. One fun little thing, this challenge is essentially the back end to this game that when I taught for Chicago Public Schools, there was always days where the kids would take tests and then they have to stay in school until 2 p.m., but they were done at 12. So we just gave them computers and they played math-ish kind of games. So it says coolmathgames.com. There's one called Papa's Freezeria. Essentially, you are writing the back end to this. So just... Okay. I'm going to turn down the music a little bit. But essentially the game is basically, you can see I've done this with other people. New, I'm going to be Alberto. I have my new job. And Alberto is taking on different people's ice cream orders. Based on their ice cream orders, he's going to blend things together. If things are, well, you can kind of see, stress-free work. All right. Somebody wrote the code that goes behind this game, right? And I'm actually fairly certain that this that the ice cream and freezers is fairly similar concept to what's going on behind the scenes here. So this is the build station. I have a bunch of syrups and mixables here, the mix station, etc. How do I go back to just the main area? Okay. So I got my first customer walking in. They're going to tell me what they want, and then I have to build everything together and take the order. Looks like the person wants a medium, sundae, strawberry, in a certain blend with these specific toppings on there. If you're really bored, like really bored, you can play this. It's kind of fun. It gets really crazy because they have like eventually. I was watching when the kids were playing. There was at one point like 7 or 8 different orders that they had to keep track of. So it was kind of fun. So I drag it up here, go to the build station, pull it over here. And then this little like cursor here is basically the concept when we were doing the ice cream. Like is it going to be too watery? Is it going to be just right? Is it going to be, there's a certain timer that you have to hit. I'm going to try to hit as close to the middle as possible. I didn't get it. That's okay. I'm going to add in my strawberry syrup. Same thing over here. Like you have to catch it right at the right moment. Get the vanilla's topping. Oops, messed up a little bit. And then I put it inside of any one of these things. As it blends, you have to basically match it up with a certain specific time. Otherwise, it's going to be, too watery, like overdone, et cetera, et cetera. So it's still going, it's still going. My computer's freaking out because it's using a lot of power. All right, I'm done here. You can kind of see this game. I'm almost done. I'm just going to do the toppings, then she'll give me a rating whether she likes it or not. Looks like I need sprinkles. One, 2, and 3. Finish. Drag the ticket here. Comes over. And then this person's going to give me some sort of rating based off of, she gave me 97 points out of 100. Okay, it's not too bad. And that's kind of like the back end that powers it is probably some sort of, there's some bit of code that powers that. Based on the actions that you take on the page, how long, if I left the thing in the blender for too long, it's not the way that the customer wants it, and thus it's overdone. It's like, how does the program know that it's overdone? You know, obviously you can see it, but there's code behind it as well. So I'm going to start with ice cream and freezers, and we're going to take a look through the summary of what we want to do. So we want to build a program that helps our manage our ice cream freezing, and here's a few stories that we've been given by the customer. As an ice cream maker, who's the main person, I want to make different batches of ice cream, peanut butter, chocolate chip, etc. As an ice cream maker, I want to place the batches of ice cream in a freezer. So I'm starting to see like which two different, like, do I have different classes that I need right away? It looks like I need to make ice cream, I need to make freezers. And then as an ice cream maker, I want to know when a batch of ice cream is ready to be removed from the freezer. So with release number 0, I'm going to design the structure. What are the essential classes? So I've given these very small stories right here. It looks like I probably need ice cream, probably need a freezer of some sort, and then I need probably some concept of a timer in order to know when to take certain things out. So we'll start with this first one, different types of ice cream. Now everything, we're putting everything inside of one giant class for right now, just so that you don't have to require different classes. For the demonstration of today, I'm going to actually move this out of there. So I'm going to have a specific class for ice cream. I'm going to have a specific class for a freezer. And we'll just start with that for now. I'm actually going to nuke this one completely. Get rid of that one. And then for every single class that I write, I also want to have a corresponding spec file. So instead of throwing everything in one place, I'm going to actually have 2 different spec files. So I'm going to get rid of this to get started. I'm going to create a file called IceCream and then I'm going to have another one called freezerspec.rb. I'm going to split the screen into 5 for now. Actually, no, I'll just split the screen into 2. Okay. Specs on the right and code on the left. All right. First things first, I'm going to require relative for ice cream, because I'm going to be using the ice cream class within here. I'm going to describe the ice cream class. And I'm going to have a few different methods. So when we think about object orientation, think of like, let's pretend this is like a half pint of ice cream. I'm going to look at the half pint of ice cream. I'm going to ask it certain questions, and it's able to tell me certain things about itself, and it's able to do certain things. What are some things that you would want the ice cream to be able to tell you? Flavor, right? So probably describe flavor. It tells me what its flavor is. All right, what else? So let's go back to the requirements real quick. It says, I want to put different types of ice cream inside of the, inside of the freezer. It looks like ice cream just needs a flavor for right now. Are we good with that? Anything else that ice cream can do? No? For right now. Cool. So we wrote the tests. Let's just do expect ice cream dot new. I'm going to pass in peanut butter dot flavor to equal flavor to equal peanut butter. It's a simple test. When I create a new ice cream and I create it to be a peanut butter flavor, when I ask you what flavor are you, you're going to tell me it's a peanut. The ice cream is going to tell me that it's peanut butter. Run the test real quick. RSpec ice cream spec. It fails because there's no code inside of there, and we're going to make this pass now. So definitionalize. So me as an ice cream creator, when I create a new ice cream, I tell it what flavor it's going to have. So it takes in a flavor, that flavor equals flavor. And is this flavor something that can be read, written, or both? Both? You're going to overwrite the flavor?
Oh, well, just red.
Just red. All right. What else can ice cream do? I'm not terribly finished with this.
Mix.
What's that?
Mix.
Think of it, does an ice cream mix itself, or does it an ice cream maker mix the ice cream? Ice cream maker mixes the ice cream. So the ice cream just can tell you what flavor it is, and the ice cream, I also think, can tell you what status it is. Right? So it's kind of like if you open a thing of ice cream, and then let's pretend you just ask the ice cream can talk back to you, like, what's your status? Right? It's like, oh, I'm watery, or I've melted, or I'm freezer burned, or I'm almost ready, et cetera, et cetera. Like, you know how like you have those super, like the people who romanticize baking, it's like the bread talks to me kind of thing. It's kind of that type of thing, or like the meat talks to me when I'm barbecuing stuff. So I'm also going to say that when the ice cream is first created, it has a status of watery, and this status is going to change over time based on how much time I'm going to be putting it inside the freezer. The status, since it's going to change, can it be read, written, or both? Both, which makes it an adder what?
Excessive.
Adder accessor. Status. I'm fairly certain that this might be it, so I'm just going to say describe hashtag status. It returns the current status of the ice cream. So when I call the method .status on it, it's just going to tell me what it is. So right at the beginning, I'm just going to have some random ice cream. So expect ice cream.new with peanut butter. And then .status, I expect that to equal watery. Because when I first create the ice cream, it's just going to be a watery mix. Run the test here. I'm pretty sure both of them are going to pass, and we're good to go. Before we move any further, does anyone see any room for refactoring? So I did red, green, and now can I refactor anything? Am I repeating myself anywhere? Yeah, Dan.
Yeah, you could create a IceCream.new instance at the top.
Yeah, it looks like I have this line is the same as this line here. And because I'm repeating myself, I can probably reuse something. Now, the way that we're going to use this part, we're going to create an object that we can use in these two tests, so we only need to create one time. The way that we do it usually would just be ice cream equals IceCream.new with peanut butter. Unfortunately, in our spec, there's a domain-specific language. There's a very specific way that they would like you to write this and to interact with this. So I need to put a let in the front of here, make this into a symbol, get rid of the equal sign, the whole thing surrounded by curly braces. This is unfortunately just how it's done. Sean?
Do you ever just like initialize the class at the top the way you would where the requires hanging out and then have your test go there?
No, not in this one. Oh, I also don't think it's in Mokuchai like that either. Usually what they will do is they will create all the variables that you need at the very top underneath the describe, so that you can, like, it's the same concept. I'm doing it all at the very top so I can use it in the test below.
But you keep them inside of
I do keep them within.
And do you nest like the testing of methods inside of that, or do you have that hanging doing something?
Yeah, so the way that I'm setting up these describe, that's a great question. The way I'm just setting up the describes here is I'm describing one specific class inside of one specific file, and that's only testing one other specific class. Inside of IceCream, there are different methods. The flavor only does one thing, but if it did two things, I would test everything underneath hashtag flavor. If status did more than one thing, I would have multiple if blocks. So for me right now, it's just kind of it's kind of interesting because it's just one describe block with one real test underneath. But sometimes, like if you were to write software for writing tests for depositing cash at an ATM, there's many things that happen, right? It accepts the cash, it updates the balance, it updates your online balance, it like creates an audit trail for accounting and things like that. There's a whole bunch of things that you would have to test within deposit cash as a method.
So, okay, I mean, I've done this thing where I wrote multiple tests for a single method.
Yeah.
Just to play with it.
Yep.
But is there like an industry standard idea for like, since you will have to initialize the class in your test, is there a specific idea that you always have your initialization and your first block described, and then you nest your other tests inside that? Or can you just have one block of described, you initialize it, and then another block of described for various methods?
The second one. Yep. Cool. All right, so we took care of ice cream. As of right now, it just returns you the flavor and the status, and that's about it. Let's talk about the freezer. What are things that the freezer can do? So I'm going to require relative for freezer. Describe freezer, do. What are things that freezers can do?
Store stuff.
Store stuff, right? Like, so when let's say I am the creator of Sub-Zero, high-end ice cream freezers, right? When I'm creating a freezer, what is something I can initialize my freezers with?
Timer.
Does a freezer have a timer on it?
Sure.
Cool, we can do that. We'll run down that rabbit hole, but keep in mind that you chose to run down this rabbit hole. So a freezer has one timer on it. Okay. What else? Like, let's say you're a shop, like you're redesigning your kitchen in your multi-million-dollar mansion after you've had a successful career in tech, and you want a Sub-Zero freezer. Like, what are the things that you need to worry about?
Storage space.
Storage space. What else? Like maybe materials and things like that. For us today, we're just going to worry about storage space. So describe. Maybe we'll call this max capacity. And the test will just simply say it returns the maximum capacity of the freezer. So since I'm going to be using a freezer over and over again, I'm going to do let freezer up here. Freezer.new. And how many things do you want this freezer to hold? How many things of ice cream do you want this freezer to have? How much space? 5. Great. So when I call expect freezer.max capacity, when I call that, I expect to get 5. Right. If I were to run the test, you'd obviously see it fail because it's not doing anything here. So when I first create this, it's going to take in a max capacity. And then at max capacity equals max capacity. Is the max capacity something that can be read, written, or both?
Read.
Read. Yep. It's not going to get any bigger. Otherwise, it's just another freezer. Add a reader for max capacity.
So since the max capacity will always be the max capacity, can we just do a default?
What's that?
Can we do a default on the max?
Well, I have different size freezers.
Sure.
Yeah. So let me run the test here. rspec freezer spec.rb. One example, 0 failure. All right, so I have ice cream. We're pretty much finished with this one. We have freezer with the max capacity. How do we know what's inside of the freezer? The freezer, should the freezer be in charge of knowing what is inside itself?
Yes.
Yes, okay. I agree with that. How do we get there? What do we do in order to keep track? What's a good data structure, first of all, to keep track of multiple things inside of it? An array? Cool. Maybe we'll create something called @storage equals that. Just an empty array. When I first create the freezer, it can hold 5 things and has nothing inside of it.
Can we change it to a hash?
What's that?
Can we change it to a hash instead?
Why would you do that?
Because then each refrigerator or each thing will have like a certain value to it. Like each type of ice cream. No.
Well,
Have its own ingredients.
Well,
How complicated you want it.
it's yeah, you can do a hash, that's fine, but it makes it more complicated. It's kind of like saying it's the equivalent of having a giant bucket and throwing everything inside of it versus like having a manifest where it's like the first thing at this particular space is this particular ice cream and second and so on. I think it's just easier to keep a storage thing like this for now. Is this something that can be read, written, or both? Both. Again, my freezer has a max capacity of 5 just to get started with, nothing inside of it. So I will also test that. Maybe I'll have a describe. Actually, that's fine. What else does a freezer able to do? Freeze ice cream. That's true. I agree with that. But how do I freeze ice cream? Do I have to do something with the ice cream in the freezer before I can start freezing?
Put it in.
I can put it in and take it out. All right. So I can describe put in ice cream, and then describe take out ice cream. It adds an ice cream object to the storage array. And then it removes a given ice cream object from the storage array. So it looks like I need to also create ice creams. So let's, inside of this it block, since I'm going to be using specific ice creams that's not going to be shared with anywhere else, I'm just going to create a few ice creams. Ice cream equals, just someone should shout out their favorite. Strawberry. I always avoided strawberry when I was a kid. So I have ice cream 1, and ice cream 2. Give me 2 more flavors.
Moose tracks.
Moose tracks. All right.
Rocky Road.
Rocky Road. Never enjoyed Rocky Road because there's too much chocolate and not enough stuff inside of it. But all right, so I created 3 different type of ice creams. Again, these are local variables inside of here. It only exists within the context of 12 through 18. And I'm going to just start putting ice cream objects inside of it. So when I first create this freezer, I expect freezer.storage.size to equal 0. Because when I first created the freezer, there's nothing inside of it. I have 3 different ice creams here. I've created them. I want to insert a whole bunch. So I'm going to do ice cream. Let's say I'm going to run freezer.put in ice cream with ice cream, this first one. And I'm going to put in the second and third as well. Ice cream 1, ice cream 2. I see that hand, don't worry. At the end, I'm expecting the freezer.storage.size to equal 3. Michael.
I was just a quick question. You know how on line 13, how you have ice cream equals ice cream.new?
Mm-hmm.
Would it be wrong for us to use the variable that we put just freezer? Can we do that? Or because we're passing in a particular argument, we have to do the ice cream.new this time?
I did not understand that.
So in line 13, how we have ice cream.new and then strawberry. Instead of doing that, could we do like how we declared the variable for ice cream.new as freezer?
Oh yeah.
I'm sorry.
Oh yes. I see what you're saying.
Yeah.
You're saying, why did we do this instead of putting it up here on line 4?
Right.
I'm only going to be using ice cream, this particular ice cream for right now inside of this it block, so I just put it inside of here. I'm using freezer here, and I'm going to be also using it down here. Because I'm using it in multiple places, I put it at the very top so it's shared with everybody. So I created 3 different ice creams, and I actually might move this later because it seems like we might need to use it right here. I've got 3 ice creams and a freezer that has nothing inside of it. Then I'm going to put in ice cream number 1, 2, and 3, so these 3 in a row. And I expect at the end that the storage size is going to equal 3. And I also expect freezer.storage.last, so the last thing, to equal ice cream number 2. Just to make sure that it's put in the exact order that I expected. So when I run the tests, obviously, I didn't write the code yet, so it blows up. There's uninitialized constant called ice cream. So I'm using the ice cream class, but it doesn't exist inside of here, so I also need that require relative for the ice cream. Make that fail. there's an undefined method put in ice cream. It's fairly simple. So we'll create this now. Def put in ice cream. It takes an ice cream object. And I'm just going to do at storage dot push ice cream. All I'm doing is I have this empty array. When I first start, I'm just pushing an ice cream, and then we're done. That's about it. Let's see if this works. Freezer spec, all three examples are passing. The converse of that is I need to take ice cream out. So I've got this freezer. The freezer has a whole bunch of stuff inside of it at this particular point, and I need to remove some things. So let's say, grab all this code inside of here. Let's say we have ice cream and ice cream 1. I'm going to put in ice cream number 1, and these first two. I expect at this point the storage size to equal 2. I'm going to remove one of them, so I'm going to do freezer dot maybe take out ice cream, and I'll take out the first one, ice cream, the first one. I expect at this particular point the storage size to equal 1 because I took something out, and I expect the only thing to be left over is this ice cream number 1. When I run the tests, one of them is going to fail. There's an undefined method called takeout ice cream. I'm going to do def take out ice cream with an ice cream object that you're passing in, of which one you want to take out. I'm going to do at storage dot most the answer. Get rid of it. Delete ice cream. So at storage.delete ice cream returns you the ice cream object that was deleted, but it also deletes it from the array. Let's see if this works. There we have all of our examples. It's still passing. Am I running the wrong spec? Nope, I'm running the right spec. How do people feel about this? Feel okay? So when I create a freezer, it has a certain capacity. Like, right, it's like if I live in a McMansion, I can have a gigantic fridge that takes up an entire wall. It has nothing inside of it to begin with, and all it does is put in ice cream and take out ice cream. Now we have this final thing that we need to worry about called like the concept of a timer. How does the ice cream freeze over time? So you have to ask yourself, is an ice cream in charge of freezing itself? No. Is a freezer in charge of freezing the ice cream? Yes. So that's what we did with this put in ice cream and take out ice cream. How do we keep track of time?
There's probably some time-based events built in the rig and set off.
There is, yeah, and that's we're jumping one. That's one step ahead of where I want to be right now. But how do we what class takes care of the time?
It would need to be a separate timer.
You could do that, yeah. There's a couple of ways of doing it. One of them is you can put a timer on a freezer, which is what Michael suggested earlier. The issue with that is a timer has to have a freezer has to have multiple timers on it, and that might be a little bit challenging. So I would recommend just having a separate timer class. So I'm going to have a timer.rb, and this one I'm kind of going off the cuff, so this might not work terribly well. So I have a class called timer, and I also have a corresponding timer spec.rb. Require relative for timer. Describe timer do. And describe some method. What does a timer? What's a timer do? I guess.
It starts and stops.
Starts and stops, right? It just keeps track of time in some way, right? So start time. It returns the start time. Okay. And then what else is a timer supposed to do?
Increment.
Increment. That is true. What else?
Or just stop.
Or just stop, and then based off of that you can.
Reset.
What's that? Start, reset. So we started it. We ended. We can end it. Sure. This might get more. I'm just going to say time elapsed. I'm going to create a method called timeElapse where it returns the amount of time that the timer has been running. All right. So I'm going to go back to Sean's thing. So when I create a brand new timer, I don't need to pass in like the start time or anything. A timer knows when it started. So I'm going to have @startTime equals time.now. You can kind of see this capital T right here. This turns into a class. That's something that's built into Ruby. Because it's something I'm using outside of this class, like it's not defined within here, I'm going to have to require time at the very top. So let's just see what time.now actually looks like. Make this a little bit bigger. IRB, require time, time.now. When I do time.now, it gives me a date time object. So it has the current date, the time that it is, and then negative 0500 is where in relation to Greenwich time, the UTC mark. It's actually, just a quick sidebar, time zones are the worst thing in the world when it comes to being a web developer, because at any given point, there are 2 times of the year where time doesn't exist, during daylight savings and daylight in the spring forward and fall back thing. You always have to keep in mind, like if you have a deal that ends at a certain time, you actually have to account for daylight savings and things like that, and people always forget. So it's very interesting. Time zones are the worst things, and this hash record guys will go more into that on Tuesday. What's that? Yeah. So we have time.now, and that's what we're gonna. This is our start time. I'm gonna make this is start time something that could be read, written, or both. Read. All right. So I have when I do. Looks like I'm going to do a let timer because I'm going to be using different ones. Timer.new. Expect timer.startTime.class to equal. Let's take a look. Looks like time. There's no good. This test is kind of stupid because it says it returns a start time. The issue is because you're running this at any given time, there's no way to hard code an actual time to look for every single time. So the second best thing I can do is say, when I call start time, it actually returns me a time object.
Is there callback functions inside Ruby?
No. All right, and then we also have time elapsed. So it returns the amount of time that the timer has been running. So if I run expect timer.time elapsed, there's no real good way to do this either. Dot class to equal integer. And I'll show you where I'm going with this. I have a def time elapsed, which is just going to do time.now minus start time. Let's just see what that returns. So if we do time.now minus, let's do time.now, and we'll wait 5 seconds. 1, 2, 3, 4, 5. Time.now minus what was just returned over here. It returns me 7 seconds. This whole thing is in seconds right over here, so maybe we can transfer this into, I guess, minutes. How do I transfer seconds into minutes?
Divide by 60.
Yeah, this divided by 60, and I can round it down, right? Probably something like that. And then we will just do this dot floor, and that just brings me back down to 0. Obviously, some time will elapse when we're actually running this program, so it'll be like 400 seconds divided by 6. I don't know, was that 6.5 minutes or something like that? And it'll round down to 6 minutes. That's how long it's been the timer. I'm going to do time.now minus start time divided by 60. This is all order of operations dot floor. Maybe I'll do time elapsed in minutes, just so that you're absolutely certain. Time elapsed in minutes. So that's all a timer does. It starts, and then it just kind of tells you how long it's been going on. If we wanted to really continue on, we can just have an alert saying like, hey, it's been more than X, like a X number of time. Now we have these three classes, and we need them all to kind of play together. This is the more difficult part. Does a freezer need to know anything about the timer? Your thoughts?
To start the timer.
I see nodding from Jackie. So the freezer needs to know to start the timer. Okay. Where?
Put in ice cream.
Put it in ice cream?
No, when you put in ice cream, it should start a timer.
Okay, that's fine. We can throw in ice cream. So when I push the ice cream in, I'm going to do at timer equals timer.new. Sound like that? Okay. Because I have this other class inside of here, I'm going to throw it at the very top, require relative. Remember, require relative is for a file that you write, requires for a library. So you're saying I have a freezer, has storage capacity of, let's say, 5, and there's nothing inside of it. When I put in ice cream, I'm going to start the timer. Okay? How do I know, like, ice cream can tell me its status, if it's watery and things like that. How will the ice cream know, like, what its current status is? Like, right now, it's always watery, but I have to say, like, it's, like, almost ready, freezing at the moment, burn, or perfectly ready. Or let's just say that.
Give it a freeze point.
A freeze point? Sure. Yeah. Let's say that. Okay. So let's say def. What's that? Okay. Let's say freezing table. So ice creams all know about the freezing table, right? It's kind of like if I ask people here, like, what are the different stages of life for human beings, right? We all have this internal table of like 0 to 5 is like babies and small kids. And then we have grade school children, high school children, college students, young adults, young parents, middle age, retirees, and then old. So freezing table. So let's just say, I don't know. I did not think I was going to go with this. Watery. Actually, let's just do this. If time elapsed is, I don't know, less than.
Just do 15 seconds as like a basis. That's what it freezes at 15 seconds.
Okay, so let's do every 15 seconds. All right, so it's a 1 minute at most, right? But unfortunately, we're doing it in minutes.
Oh,
dang it.
Got it. So
let's just do 15 seconds then. So we will just get rid of this and just floor it. How's that?
Yeah.
So instead of dividing it, we're just going to floor it. All right, so if the time elapsed is less than 15 seconds, then we'll just say status equals watery. And that's what it is to begin with. So I don't think we actually need this. If it's greater than 15 and its time elapsed is less than, I don't know, 30 seconds, we can say it's currently going to be freezing.
If you start with the longest time and go that way, you don't have to do the 2 conditionals.
Sure, let's do that then. All right, so you're saying if
else it does.
Okay, let's say if time elapsed is greater than or equal to 60, then we can say it's burned. How's that?
Yeah.
Freezer burned. Else if the time elapsed is greater than or equal to 45, we can say at status equals perfect. Else it's 45. Else if time elapsed is greater than or equal to 30, at status equals freezing. Freezing now. Else watery. Actually, we don't even need to do watery because it's by default watery. Sean?
I'm just curious, like, so you just created definitions for each one?
Mm-hmm.
You're like, watery equals time elapsed, center range.
Yeah.
You catch them all into variables.
Yeah.
You could just return like a filter value on that. Just put like whatever filter from time elapsed, like as a return value.
Yeah, that's what I was thinking about doing that with like hashes earlier, but I was just kind of like, this is a little easier for everyone else to read. All right, so a ice cream returns a flavor and returns a status. It can also return you its current status based on the time elapsed. Or let's say like freeze or something like that. The ice cream could freeze, and based on the time that you give it, it's going to tell you whether or not it's freezer burned, perfect, or freezing now, or just watery if it's less than a certain amount of time. So the ice cream needs to know, takes in time elapsed, but it doesn't know about anything else. The ice cream is like the dumb person in the room. Like, it's like, I don't need to worry about anybody else. It's just everyone tell me things and I will do something. It's kind of like the drone. Everything is encapsulated within here. The freezer is kind of like the master class. It knows a little bit about ice cream. It knows a little bit about timer, and the timer just knows I start and I give you my time. So you want to have as much like single responsibility. Like, you don't want to like marry two different classes together as much as possible. So right now there's one single point of failure, which is the freezer class, which is okay. But I don't want everything else to know about each other as much as I can. The ice cream can exist on its own. The timer can exist on its own. The freezer is essentially like the ice cream maker in this case.
Okay.
Yes, yeah.
So, like in this world that we're creating between these files, like you can only essentially initialize and run one thing off of some file somewhere to then have it kind of play out. There's no way of keeping track of things.
Yes, as of right now, yeah, there's no real way to keep track of like where everything is until you start writing to a database or you start writing to a CSV, which is where we're going. Dan?
I was just looking at if you go back to the ice cream file, we're saying time elapsed there, but where is it getting that from? So I think we probably need to move the timer that we put in the freezer to the ice cream.
No, think about it. So so the question was like this time elapse, where does that come from? As of right now, it does not exist inside of ice cream, and I did that on purpose because the ice cream should not be able to start the timer, because it's the person who's actually putting the ice cream inside of the freezer who should be keeping track of the timer. The ice cream is just in charge of returning its flavor to you and telling you what it is, and then it's just kind of like when you actually go to like Baskin Robbins or something. All the ice cream does is like it has a little label that says this is what I am, and then you can kind of see it's like, oh, somebody left that in there for a little bit too long, or hey, no one's eaten that for a while, so it's completely,
Okay,
iced
so
over.
will the freezer class be the one that calls the freeze method?
Yes.
Okay.
Yeah.
And also I noticed that timer that we start is not associated to any particular ice cream.
Not yet.
So every time we put one in the freezer, it's just going to start a new timer.
Exactly.
But we won't know.
Yeah, but then we can actually change this data structure from the array into Michael's hash that he wanted. So it's like now I can start changing things around because I need to keep track of the timer for each individual one and the ice cream for each individual thing.
Okay.
Tristan?
No.
Okay, cool. All right, so I'm going to do this for another 5 minutes and then 2 minutes, and then we'll take a break and then we'll come back. But now we need to worry about, so the freezer has a storage. It pushes ice cream inside of it, and it's in charge of the timer. Ice cream is just like one of those like people who's just like, all I know is what I know. I don't know anything about anything else. Same thing with the timer. It just knows how to start and to calculate its time. That's all it's supposed to do. So at this particular point, I'm pushing in the ice cream, and I need to start a timer, like a fairly quick timer. So I can either throw it inside of an array like this, or I can throw it inside of a hash. It's up to you.
Array would probably faster.
It's just faster for right now. Okay, so I push the ice cream inside the freezer. I start the timer, and somehow I have to associate the ice cream and the timer. I did not want to do this, but I could just do add storage dot push timer. And then so the two things that are right next to each other, that's not the greatest way of doing it, but it's a little brittle, as you can start to see. The ideal one would be to do it in a inside of a hash like this, where it's just like, hey, number one has this array of this ice cream and this particular timer, and then it's always going to be together like that. But that's okay.
But I mean, you could also just have initialized variable with some timer that's at 0 start. No?
Yes, but the freezer, it's each individual ice cream has an individual timer on it, right? So it's like once I put.
Oh yeah, okay.
And then finally, to call the ice cream and basically see like what the status is. Like, oh God, we could just do def. I'm not sure. I'm actually going to change this real quick. Essentially, what I would do is just have a. I'm going to do.
It feels to me like that whole method should be in freezer, not in ice cream.
You feel like which one?
The method that's in ice cream for the status.
Yeah.
Or the freeze.
Yeah.
I feel like that should be in freezer.
Okay.
Because it doesn't really use anything that's in ice cream. And
I agree and I disagree at the same time. And these are these kind of like fun decisions that you get to talk through. This is, I'm going to stop right here just so that we're not like banging our heads against the wall, but you kind of get like how I started to like think through which class is in charge of what, how do they talk to each other. Like when I use require relative, like because I have a timer class inside of the freezer, I need to require relative because it exists somewhere else. So I hope this was slightly helpful. Let me take this question and we'll take a break.
I feel like the hardest thing with all this is just making your decisions on how you're going to design what gets what.
Mm-hmm.
That seems to me like that for me, because I could do this, make these things talk to each other. But like, what should go where? Yeah,
that's a great point. So his comment was the most difficult part about this is not necessarily the instance variables and the methods and stuff like that, but it's just like what class does what. And I will say that is where you should spend the majority of your time. It's like what classes do what, how will they talk to each other, and like how many classes do I need, et cetera, et cetera. And every single choice that you make now will have some sort of consequence down the road, whether they be good consequences or bad consequences. For companies that are like, I have $6 million of cash and I need to get something out the door in the next year, and they need to blow through all of that money and get something out the door, they will make bad tech decisions that may not be the best, but they don't have enough money to make the best decisions because they don't have enough time. So they will eventually have something called tech debt, which I'll talk about after I pause this recording.